All right, welcome to Chapter 5, Section 1, called Postulates and Paragraph Proofs. So just a few things when we start this off. Oh, this is for Integrated Math 2, or IM 2. So now, just a few things to start this off. You should see a due date on your screen. That's one of the first things you should see here. I don't see it on the teacher preview, but it'll be on your screen as a student. The second thing is attempts. We always allow unlimited attempts, meaning you can come in and submit this assignment as many times as you would like. Number of questions just tells you how many are on this assignment. So this one has 2 questions. Grading policy is always best score, so whichever attempt is the best one is the one you keep. Partial credits enabled, so if you only answer one of the 2 questions, you get credit for your 1 question. This reminds us that once we start our homework, we have to finish it before doing anything else, and that has to do with submitting. So once I click start, down here in the bottom, there will be a submit assignment button, and I need to make sure that I click that button if I'm leaving the screen. So as soon as I'm ready to leave, even if I haven't started anything, or maybe I've answered one of the 2 questions, I click submit assignment. It's going to save my place. It's going to know where I left off, as long as I've clicked check and I've gotten green marks or anything like that. It's not going to know if I've done part of the problem. So it'll know if you've gotten an answer correct, and it'll start you off where you left off. 2 things. It'll stop the system from locking you out if you click the submit assignment button. It'll also affect the grade book when you do that. So your teacher can see that you've been working on it, and it should make an improvement in the grade book there. On the side, we always have these 3 pieces. Explanation tells you you're going to lose your question attempt because it's going to give you the solution to this question. So it's not going to give you the solution and then let you come type it in. You'll have to try that on another attempt. Example will explain to you what it wants you to do. So in this one, there is a little bit of background. Actually, once we start the geometry, there's quite a lot of background we need to know. So with this one, collinear, whenever we hear co and linear, so co means like to share or the same, linear means line. So if I'm asking about collinear points, there are points on the same line. Same thing with coplanar. Coplane, and I'm losing my mind. Are there 2 ends in coplanar? Nope, just 1 end. So this means like to share again, and this is a plane. Plane, and I think there is an E on plane, not plan, plane. So these are some basic ones, that we have here with a line. So any 2 points make a line. There can be more than 2 points, but any 2 points make a line, and we can label that AB like this, or we could label it BA. We could go backwards like that. Sometimes there's also like a little cursive letter there, like an L. We could call this line L. So there's all kinds of different ways to do that. For a plane, it's any 3 points. Think of a triangle, at least a triangle. We need 3 points, so 3 non-collinear points, because if I put 3 points on a line here, they don't make a triangle. And we would label that with the 3 letters. So we'd say plane ABC, we could say BCA, CAB, ACB. It doesn't really matter, as long as we use 3 of the letters there. So these are the main kind of definitions we need to complete this one. So with the definitions, or with the geometry part here, we're definitely going to need to be looking at our prior knowledge here, our explanations, because if we don't look at these pieces, we're probably not going to know what all of this means right off the top of our heads. So anyway, we've gone over the explanation there. The last piece is the message center, so you can always message your teacher if you need to, and this attaches the questions so we know what to come help you with here. Okay, so we've gone over some of the definitions that we do need here. This was just general examples that I threw out. So we have in the figure below, F, C, B, and A lie in plane X. So these guys are coplanar. A, B, C, they lie in the same plane. So they share a plane. We call that coplanar. Points D and E do not lie in the plane. So we can think of this if we had a piece of paper, and this is like a pencil that we stabbed through it. And here's the lead, and here's the eraser. And it's just kind of a pencil that's stabbed through the piece of paper. So this line is going through the plane. It's not on it, it's going through it. So for each part below, fill in the blanks and to make the statement true. So for A, it says, Something and C are distinct points that are collinear. Remember, collinear means to share a line. So I want C and I want it to share a line. So I could choose A or B, and when it says distinct points, it means different points, so you can't choose C again. But I could do A or B. They're both on the same line. Doesn't matter which one I choose. Both of them are the correct answer. So now ED, so I have this one, this line here, ED, and blank are distinct lines, different lines that intersect. So I have this line here, and then I have this line going through it. So remember, 2 points make a line. I know there's A, B, C on that line. I only choose 2 of those to name it. So I can name it AB, I can name it BA, I can name it BC, CB, AC, CA. There's 6 different possible names there. So I'm just going to go with AC, beginning to end, because it's really not a big deal. Blank, blank, blank. So A, blank, blank, and blank are distinct points that are coplanar. Well, we already kind of talked about that. It told us these 4 points lay on the same plane. So A, B, C, and F, they kind of gave us that answer. B, C, oops, C. Why isn't it going to the next one? C, I can't press the arrow. I got to press the tab button, I guess. And F are distinct lines, different points, that are coplanar. Another name for plane X, that's this cursive-y, it's not super cursive-y, but it's this letter up here in the corner that doesn't have a point next to it. That's the name of the plane. So this is another name for this plane, could be, and what we need to do is choose any 3 points that are on the plane that make a triangle. So we can't do ABC. Those are not 3 non-collinear points. They make a line. We need them to be off. So I'm going to choose 2 of those points. I'll go AC and then F, because that makes a triangle. I can go ACF and then I can connect it back and that can be a triangle. I could go ABF or AFC, AFB. I could start with F and go FCB, FBA, FAB. Really doesn't matter what order I put this in. There's a ton of answers here. The main thing is I need to follow that rule. It has to be 3 non-collinear points for a plane. 2 different points make a line. So that's why I did 2 here and 3 here. It's different objects. One's a line, one's a point, or one's a plane. All right. So now we're going to look at here, and we're going to look at the difference between a conjecture, a theorem, a definition, a postulate, and an undefined term. So if we click explanation, this gives us the definitions for these pieces, and I know I gave you these on the notes pages. We went through and we defined these in class. So if we look at these, a definition is the meaning given to a term. It's a formal statement. So if we're talking about any kind of formal statement that describes a term, that's a definition. A conjecture is a statement that may be true, but it's never proven. So it's kind of a guess based on knowledge. So it's a good guess, but it hasn't really been verified, or it's not false necessarily. It has been shown to be false. But when we use the word guess, a lot of the time we're thinking conjecture. And it's not a wild guess. It's usually a smart guess. A postulate is a statement that is accepted as true without proof. So it is used to prove other statements, often as part of a theory. So we use these moving forward to move forward to theorems. A theorem is a statement that has been proven to be true by accepted arguments. So it may be deduced from an example, definitions, postulates, or other theorems. An undefined term is usually is a term that is not given a formal definition. So in geometry, 3 undefined terms are point, line, and plane. And another thing that I think of with point, line, and plane are they're kind of imaginary figures that we give meaning to, but a point is infinitely small. It's not something we can actually see, but we draw a point as a dot. We give it something. We give it a formal meaning. Same thing with a line. Well, a line isn't really represented this way, but that's how we picture it. But that's not, a line wouldn't necessarily be big enough for us to see. Like, it wouldn't be a tangible object like this. Same thing with a plane. We tend to draw rectangles for planes. But rectangles are infinite. They expand in all directions infinitely. So to make it just a small rectangle kind of cuts it off a little bit. It just makes it more conceivable for us to think about. So that's why these are undefined terms. We can think of them as they're a little bit imaginary. We imagine them this way so that we can kind of manipulate them and make more sense. So Caitlin is trying to prove a statement about all prime numbers that she believes is true. No proof of the statement exists. So with this one, we want to look for kind of specific words there. So it's not going to be a definition because there's no formal statement. She believes it's true, but there's no proof of the statement that exists. So with this one, I'm pretty sure we're going to go with conjecture. It doesn't say guess on there, but she's trying to prove a statement about prime numbers that she believes is true. Lasonda, I think is how you say that name, provided a certain statement about polynomial functions. Proved a certain statement about polynomial functions. So she proved it. That would not be a postulate. Postulates are accepted without proof. So a theorem, I think, is what they're going for here. The statement is best described as a theorem because it was proven. Maria wrote a proof that included the following statement. The statement formally describes what a right triangle is. So a formal description, a right triangle is a triangle with one right angle, that's a definition if we're formally describing something. Michael wrote a wrote a proof that included a certain statement. The statement is not a definition, but is accepted as true without any proof. So if it's accepted true without any proof, that's the exact definition of a postulate. That's how we define that. In his textbook, Jose found a proof of a certain statement about a right triangle. So he found a proof of a certain statement. I believe we're going to go with theorem on that one. Let's check. Yay. So these ones can be sometimes a little bit difficult just because we're matching up so many different terms that we just learned. Some of these, hopefully, we understood the idea of what a definition was. But postulate, theorem, conjecture, undefined terms, these are all pretty brand new ideas that we just learned for geometry just now in this section. So that was section 1. I will see you in section 2.